A security tester finds a vulnerable server, proves the weakness, and reports it. A criminal finds the same server, takes data, and hides the evidence. The keyboard may look similar. The authorization is completely different. Ethical hacking is the controlled use of attacker-style thinking to improve security. Penetration testing is a structured engagement that validates whether weaknesses can produce real business impact only inside an approved scope. This video gives you the complete methodology without turning into an exploit recipe. We will begin with rules of engagement, compare black box, gray box, and white box testing, then follow reconnaissance, threat modeling, vulnerability analysis, carefully bounded validation, reporting, remediation, and retesting. Here is the rule that governs everything. No written authorization, no test. Never point scanners, password tests, social engineering, or exploit tools at systems you do not own or lack explicit permission to assess. The goal is not to prove that a tester is clever. The goal is to give the owner trustworthy evidence, reduce risk, and leave the environment safer than it was before. Popular beginner technology explainers tend to work because they begin with a concrete problem, introduce one concept at a time, and keep returning to a simple visual model. They use short chapters, large labels, animated arrows, and practical comparisons instead of flooding the screen with text. We will adapt those broad teaching techniques, but every sentence, diagram, visual motif, and example here is original to CipherVibe. Our memorable analogy is a building safety inspection. The owner gives an inspector assigned work order, identifies the doors and floors that may be tested, sets hours and emergency contacts, and explains what must never be disturbed. The inspector checks whether controls actually work, records evidence, stops if safety is at risk, and delivers a repair list. A penetration test works the same way. Scope is the property line. Rules of engagement are the work order. Exploitation is a controlled proof that a door can open, not permission to wander through every room. That analogy also explains why a vulnerability scan alone is not a penetration test. A scan lists possible weak doors. A penetration test validates selected paths, impact, and controls under agreed limits. Pre-engagement is the most important phase because it turns an idea into a controlled, defensible test. Name the legal owner and obtain written authorization. List exact domains, IP ranges, applications, cloud accounts, APIs, facilities, and identities that are in scope. List exclusions just as clearly. A third-party service connected to the target is not automatically authorized. Define the test window, source addresses, rate limits, allowed accounts, approved techniques, and prohibited actions. Decide whether denial of service testing, phishing, physical access, persistence, credential attacks, data access, or production exploitation are forbidden, simulated, or separately approved. For most beginner and business engagements, disruptive techniques should be excluded. Establish emergency contacts and a stop word. Document who can pause the test, how incidents are distinguished from test activity, and what happens if sensitive data appears. Minimize collection, encrypt evidence, restrict access, and define retention and deletion. Agree on success criteria and reporting severity before the work begins. The tester should know what evidence is sufficient and when to stop. Legal and regulatory requirements vary by location and contract. Fact-check those details with qualified counsel and the system owner before testing. The three common approaches differ mainly in how much the tester knows. Black box testing starts with little internal information. It approximates an external attacker's view and is useful for testing internet exposure, discovery, and monitoring. Its strength is realism. Its weakness is limited coverage. Time may be spent rediscovering facts the organization already knows. Gray box testing gives the tester selected information or a normal user account. It is often the best balance for web applications, APIs, cloud environments, and internal networks because it tests real trust boundaries while using time efficiently. White box testing provides architecture, source code, configurations, credentials, and collaboration with engineers. It offers the deepest coverage and makes subtle design flaws easier to find. It is ideal when assurance and remediation detail matter more than surprise. Testing may also be external, internal, web, API, mobile, wireless, cloud, social, or physical, but each area needs explicit scope and suitable expertise. Choose based on the question. Use black box to ask, what can an outsider reach? Gray box asks, what can a user or limited foothold do? White box asks, where can this design fail, including paths an outsider might never discover during a short engagement? Reconnaissance builds an accurate map before deeper testing begins. Passive reconnaissance uses information already available to the tester, authorized documentation, public records, certificate data, published endpoints, code supplied by the owner, and interviews. Active reconnaissance sends traffic to in-scope systems, so it must follow approved rates and windows. Do not treat every discovered hostname as fair game. Confirm ownership and scope before touching it. Cloud services, content delivery networks, software as a service platforms, and vendors may belong to someone else. Now add threat modeling. Mark users, administrators, services, APIs, databases, secrets, remote access, trust boundaries, and valuable business processes. Trace how data and authority move between them. Then write hypotheses. Could a normal user reach another customer's record? Could an exposed service lead to a privileged control plane? Could a leaked token cross from a build system into production? These are questions to validate safely, not assumptions. Prioritize paths using likelihood, exposure, privilege, data sensitivity, operational impact, and existing controls. This is where a checklist becomes a story. Assets connect to identities, identities reach services, services protect data, and monitoring should observe the important transitions. Vulnerability analysis combines automated coverage with manual reasoning. Scanners can identify missing patches, expose services, weak headers, configuration patterns, and known software issues. Static, dynamic, and dependency tools can help with applications. But tools produce false positives, false negatives, and context-free severity. A human must verify the condition and connect it to business impact. Exploitation in an authorized test means controlled validation. Start with the least invasive proof. Use test accounts, synthetic records, canary files, and isolated environments whenever possible. Capture enough evidence to demonstrate the weakness, then stop. For example, suppose a gray box test checks a training portal with two owner-provided accounts, Learner A and Learner B. The tester observes that changing an object reference may expose Learner B's synthetic profile to Learner A. The safe proof retrieves only the seeded test record, records the request and response, and stops. It does not enumerate real users or download a database. That evidence establishes broken object-level authorization and impact without expanding harm. Avoid unnecessary persistence, destructive payloads, broad credential collection, production data extraction, or pivoting beyond scope. If a test unexpectedly creates instability or reveals real sensitive data, use the agreed stop process immediately. Post-exploitation is frequently misunderstood. It does not mean doing everything an attacker could do. It means answering agreed impact questions with minimal risk. Can the validated foothold reach a more privileged role? Does network segmentation prevent access to a protected system? Could one compromised identity affect multiple environments? The rules of engagement decide which questions may be tested and how. Use the building analogy again. Proving that one authorized test key opens a restricted door may be enough. You do not need to enter every office, photograph every document, or leave a hidden entrance for later. Coordinate closely when validation may touch production, privileged identities, sensitive records, endpoint controls, or monitoring. Prefer simulations, canaries, and owner-observed demonstrations. Record timestamps so defenders can compare alerts and logs with tester activity. Persistence should be prohibited unless explicitly required and tightly controlled. Any test account, temporary key, uploaded file, agent, firewall change, or configuration adjustment must be inventoried and removed. Cleanup is not complete until the owner verifies it. The test must never conceal activity from the owner, weaken security for convenience, or leave a reusable access path. Ethical testing ends with the environment under the owner's control. The report is the main product of a penetration test. Executives need the overall risk story: what was tested, what important paths succeeded, which controls worked, and what should be fixed first. Engineers need exact affected assets, prerequisites, sanitized evidence, root cause, remediation options, and validation steps. For every finding, explain the condition, attack path, demonstrated impact, likelihood, confidence, and scope. Distinguish verified facts from assumptions. A severity score can help, but business context decides priority. A moderate technical flaw protecting a critical payment function may outrank a high scanner score on an isolated lab system. Include positive observations too. If segmentation, least privilege, detection, or rate-limiting stop-to-path say so, that evidence helps the organization preserve effective controls. Sensitive reports require protection. Store them in approved systems, restrict distribution, encrypt them in transit and at rest, and remove secrets or personal data that are not needed. Do not paste exploit evidence into public tickets or broad chat channels. Finish with an ordered remediation plan, immediate containment, durable root cause fixes, detection improvements, owners, target dates, and any temporary compensating controls. A report that cannot guide action is only a description of risk. Remediation is where testing creates value. Fix the root cause whenever possible. If an application trusted a user-supplied record identifier, enforce authorization on every server-side object access. Do not merely hide the identifier in the interface. If a service was overprivileged, reduce its permissions and review other services built from the same template. Developers and operators should reproduce findings in a controlled environment, add automated tests where practical, update architecture or configuration, and improve monitoring for the demonstrated path. Retesting is targeted verification, not an automatic new engagement. Confirm that the original proof no longer works, test closely related variants, and ensure the fix did not break legitimate behavior. Stay within the agreed scope and test window. Classify each item clearly: fixed, partially fixed, not fixed, accepted risk, or unable to verify. Record residual risk and the evidence used for closure. One pentest is a point-in-time assessment. It does not guarantee security. Significant releases, new internet exposure, identity changes, cloud migrations, acquisitions, and major control changes can create new paths. Combine periodic penetration testing with secure design, code review, vulnerability management, configuration monitoring, logging, incident exercises, and continuous improvement. Finish with a complete checklist. Get written authorization from the actual owner. Define exact scope, exclusions, test windows, allowed techniques, rate limits, emergency contacts, stop conditions, evidence handling, and cleanup. Choose black box for an outside view, gray box for efficient testing across real trust boundaries, and white box for deep assurance and design analysis. Begin with passive reconnaissance. Confirm ownership before active testing. Map assets, identities, data, trust boundaries, controls, and business impact. Build prioritized hypotheses instead of launching tools without a question. Use automation for breadth and manual analysis for context. Validate selected weaknesses with the least invasive proof. Use test data, stop when impact is established, never expand beyond scope, and coordinate immediately when safety changes. Avoid the classic mistakes: testing without permission, vague scope, treating scanner output as truth, chasing impressive exploits over business risk, collecting unnecessary data, leaving artifacts, hiding instability, and delivering a report with no repair path. Report verified evidence, root cause, impact, confidence, and prioritized remediation. Protect the report. Retest the original path and nearby variants, then document residual risk. Remember the building inspection. The signed work order comes first, the property line matters, and opening one test door is enough to prove the lock needs repair. Authorized. Controlled. Evidence-driven. That is ethical penetration testing. Copyright 2026 CipherVibe. All rights reserved.